So isomer refers to the structure of a compound which are having a same molecular formula but different structures. We call them as isomers. So we can draw the isomers of alkene, we can draw isomers of alkene and isomers of alcohol. These are the three main isomers you should be able to draw as well as name them. But first part we will discuss how to draw the isomer, and the second part how to name them. So drawing the isomers of alkanes. So alkane means the general formula of alkane. How do I recognize that the compound is alkane? The general formula of alkane is CnH2n plus 2. So the number of the hydrogen are twice as compared to twice plus 2 as compared to number of carbon atoms. So if I say I want to draw an isomer of alkane, two isomers of alkane, C5 and H12. So first what we draw 5 carbon atoms in a straight line. 1, 2, 3, 4, 5. Then we make a bond between the carbon atoms. So 1, 2, 3, 4. They will have a single bond. Why they have a single bond? Because it is an alkane. If a compound is an alkane, it will always have a single bond. Then how many hydrogen this will have? The left hand side carbon. How many hydrogen this should have? How many hydrogen the left hand side carbon should have? 3. That's right, because carbon maximum can form 4 bonds, so this will have 3. Then this is the next to that will have 2 because 2 are already formed. Next to that is 2. Next to that is also 2, and next to that is 3. This is 1. Now to draw an isomer, what we do? We draw like make a branch one. So 1, 2, 3, 4. So we draw 4 carbon atoms and then we make a branch. But remember, this is a very uh, common mistake which student used to make, that they try to make a branch with the first carbon. That is not right. Branch cannot be there with the first carbon. Branch always started with a second or a third. It cannot be with the first carbon. So I cannot draw a branch with a here on the left hand side, that will be wrong. Or I cannot draw a branch here on the far right hand side, that will be wrong, because that is not considered as a branch. So branch it should be in between there, and I can draw up or down. That does not make difference. So 4 carbon, then I put one more carbon to make it 5, and now link them together by a single bond. Each carbon, because it's an alkane, and if it's an alkane there should be a single bond between the carbon atom, and then remaining hydrogen will draw. This will have 3 hydrogen, this will have 3 hydrogen, this will have 1 hydrogen, this will have 2 hydrogen, and this will have 3 hydrogen. So we draw the two structures. These two are known as isomers. Isomer means they have the same molecular formula but different structure. So if we want to draw the isomers, the isomer of alkane, what we do, we make first one as a straight chain, and the second one as a branch. So that's how we draw the two isomers of alkane. The first one is a straight chain and the second one is a branch. And how you can identify whether you did accurate, like you made a right structure, just count the number of the carbon atoms and number of hydrogen. That should be same in both isomers. So when I count here, I have 5 carbon and 1 2 3 4 5 6 7 8 9 10 11 12. So C5H12. And when I count this one, 1 2 3 4 5, so C5, and 3 6 9 10 11 and 12, so C5H12. So they should have the same molecular formula, but their structures will be different. So when compounds have the same molecular formula and different structure, we call them as isomers. And to draw an isomer of alkane, how we draw? We just make one as a straight chain and another one is a branch. And keep in mind, you cannot place a branch on the far left hand side or the far right hand side. The branch should be in between. Is it clear that how to draw an isomer of alkane? Now, if I want to draw another isomer, like example C, yeah, we can make as much as we can. We can make the third as branch as well. That's true. But normally in exam, you'll find they ask to draw 2 isomers. So when you're drawing the 2 isomer, we can make the third branch as well. That will be another isomer. But as in O levels, maximum they ask to draw 2 isomers. So if they ask alkane is given and you have to draw 2 isomer. So first one, make a straight chain, and the second one you will try to make a branch. The third one you can also make as a branch, but you need only 2 of them. So another example, if I want to draw an isomer of C3 and H8. So 3 carbon, so prop, 3 carbon prop, and because there is an alkane, so it is propane. Now I want to draw so if I want to draw an isomer of this 3 carbon, first I draw the straight chain. And then I put a hydrogen. Because it's an alkane, so they will have a single bond. How many hydrogen this carbon will have on the left hand side? This will have 3. Then this will have 2. And this will have 3. So this is 1. When I try to draw the second one, I draw 2 carbon, but as I mentioned, like if I want to make a branch, it should be at the center. If I draw like this, that is not a branch. So if I try to draw like this, that is not a branch, because the branch should be there, not on the far right hand side, far left. It should be between the carbon. So because I cannot adjust any branch here, so what happened? This does not have any isomer. So there is no isomer of, it has only one structure. It does not have isomer. No isomer means there is no other possible structure. This is the only way I can draw. Even if I try to draw like this, that is not an isomer. That is the same thing. Because as I mentioned, the branch is only considered as the one which is there at the end, in between, but not at the end. So this is not a branch. This is actually the same structure, only twisted one, like we made it up. So that is not an isomer. It's the same structure. So for those compound, like for alkanes, we cannot draw isomer for first 3 of them. Methane, ethane and propane does not have any isomer because we cannot draw their complete structures, like can change their structure. So If we have methane, means CH4. If we have ethane, C2H6. And if we have propane, C3H8. For them, there are no isomers. We cannot draw any isomer. We can only draw the isomers from butane and onwards. So if I say I have a compound C5 and H12 and I want to draw example 3 isomers. You have to draw 3 isomers now. So how to draw the 3 isomers? C5, 5 carbon atoms. So 1, 2, 3, 4, 5. And then I put hydrogen. Now, instead of normally they in exam they say show all the bonds, so you should draw in a displayed form, but you can write in short like this contain 3 hydrogen. So just to save the space, I can write H3. What does it mean? It means 3 hydrogens are there. Instead of writing 2 separate hydrogen, I can write H2. This also H2. H2 and CH3. So I can represent in this manner. But if in exam they say show all the bonds in the isomer, then I cannot draw. I have to show all the bonds. So to show all the bonds, I have to draw in the same way we used to draw the structure. So this is one. Now I have to draw the second one. How to draw the second one? I will make a branch. So 5 are there. First I'll put 4. 1, 2, 3, 4. And then I cannot put a branch with the far left or right. I can put in between. So I put here carbon and I can put a branch up or down. It does not make difference. It's the same thing. Because it's an alkane, they all have a single bond. So this will have 3 hydrogen. This will have 1 hydrogen, 2 hydrogen, 3 hydrogens, and 3 hydrogen. So they are isomer. This is second isomer, but we have to draw third one. So how to draw the third one? Now I will draw 3 carbon atoms in a straight, 1 branch up, 1 branch down. I need a space to draw hydrogen, so I'll draw again. Look, 3 carbon atoms we drew. So 1 branch we put up, 1 branch we put down. Then this will be CH3. This will be CH3. This will be CH3. And this will be CH3. So this is another structure. These all are isomers. How I know they are isomer? When I count, this contains 5 carbon and 12 hydrogen. When I count, this contains 5 carbon, 12 hydrogen. When I count, this contains 5 carbon and 12 hydrogen. So when the molecules contain equal number of atoms like carbon and hydrogen but different structure, what we call them as isomers. Is it clear? The isomer of alkanes, that we just make a straight chain, then we make a branch. This is how we draw the isomers of alkane. But now how to draw the isomers of alkene? Alkene means there should be a double bond. So there are 2 ways to draw the isomers. So to draw the isomers of alkene, there are 2 ways. Number 1, we can make branch as well, but I don't advise you to make branch, otherwise you will be confused. So what is the simple way to draw? You can make first one, to draw the first isomer, change the position of double bond. Because alkene contain a double bond, so we'll change the position of a double bond. That is one thing. Second, we can draw cyclic compound. Cyclic means without any end, no end. And third, what we can do, we can make a branch. But I don't advise you to make a branch, because otherwise you will be confused. It's better change the position of a double bond or draw the cyclic. What does it mean? Like example, I will give you example. I want to draw an isomer of C4H8. C4H8 means 4 carbon atoms. So 1, 2, 3, 4. Then because the number of the hydrogen are twice as compared to number of carbon, so it means it's an alkene, so it should have a double bond. So there should be one of the two carbon atoms should have a double bond. So first I place a double bond with first one, and rest will have a single bond. It's not like big double bond with all. That is wrong. It's only like one double bond is there and rest all are single bonds. Then we put the hydrogen. So 1, 2 hydrogen here, 1 hydrogen, 2 hydrogen atoms and 3 hydrogen. This is one of the structure. Now the second structure, we'll draw the same carbon atoms, but now double bond was with the first two. Now first and second, now we'll make a second and third. So second and third should have a double bond. And then we put a hydrogen. This will have 3 hydrogen. This will have 1 hydrogen. This will have 1 hydrogen. This will have 3 hydrogen. So these two are the isomers. How they are isomers? Because they have different structure. The first one contained double bond with the first carbon, first two, like 1 and 2. The second one contained the carbon between second and third. And so we can change the position of a double bond. So it is very easy to draw isomer for alkene. Or we can make a cyclic. What is the meaning of cyclic? Cyclic means no end. But that cyclic does not have a double bond. So 1, 2, 3, 4. So if we draw a cyclic alkane, that will also be an isomer. So we draw 4 carbon atom in a ring, a cycle, like there's no end. And we link them together, and then we put the hydrogen. This will have 2 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 hydrogen. So when we count the number of the hydrogen and carbon, this will be C4H8. This is C4H8. This is C4H8. So all these are isomers. So if we want to draw an isomer, first what we can do, we can change the position of a double bond. That can be done. Or we can draw a cyclic alkane. As a result, it will be an isomer. Or make a branch. But that will make, like, sometimes we have to name them, so it will make difficult. So just make a branch. So 3 carbon you draw and 1 as a branch, and then remaining hydrogen will be there. So this will have 2 hydrogen, this will have 3 hydrogen, and this will have 3 hydrogen as well. So we can change the position of a double bond, we can make a cyclic, or we can make a branch. But I advise only do these two, like either change the position of a double bond. First thing, try to change the position of double bond. The second thing, make a cyclic alkane. But don't try to go into a branches, as it will make a complicated structure. Is it clear how we can draw the isomers of alkene? So if I want to draw an isomer of, so if I want to draw three isomers, so I want to draw three isomers of C5 and H10. So it is alkene, and we can say it is pent because of 5 carbon it is pent, and because of the double bond it is in pentene. So first what we do, we draw 5 carbon atoms, 1, 2, 3, 4, 5. Then we make a double bond between the first two, remaining we single bond. How many hydrogen this will have on the left hand side? How many hydrogen the left hand carbon should have? So it should have 2 hydrogen. How many hydrogen this will have? 1. How many hydrogen? 2. How many hydrogen? 2. And how many hydrogen? 3. Now we have to draw another isomer because it's an alkene, so it's easy to draw isomer of alkene. Just change the position of double bond. Now the double bond should come with the second and third carbon, and the rest all will have a single bond. And then put the hydrogen. This will have 3, this will have 1, this will have 1, this will have 2, and this will have 3. Then to make a third isomer, what we can make a cyclic. How to make cyclic? So 5 carbon atoms in a cycle. So 1, 2, 3, 4, 5. And then we put a single bond cyclic alkane we draw. This will have 2 hydrogen. 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 And this will also have 2 hydrogen. So this is how we draw the structure. As you can see, to know whether you did correct. So this is C5H10. This is C5H10. This is C5H10. So they all contain the same molecular formula but different structure. So when compound contain the same molecular formula but different structure, we call them as isomers. Is it clear how to draw the isomers of alkene?